let me know that you've heard me.
Yep, I can hear fine. Jeff? If you're speaking, Jeff, we couldn't hear you. Nope, we still can't hear you.
How about now?
Yes, I hear you very low, but I hear you. Stuart?
Yeah, I'm talking later on, so I thought I'd better check that you can hear me.
Yep.
Hey, Alvaro, since it's not clear if like Jeff and I will switch over to chairs in the Meet Echo controls, can you make sure you stay here in case you need to sort of act as chair for the second half?
Yes, we will stay here, and no, you're not going to change the chairs.
Okay, so if there are any controls that we need to run, you need to run them for us.
Yeah.
Is that okay? Thanks.
Yeah,
Excellent.
I mean, I'll let you, one of you or Yingsen, to share your screen, of course, so you can show the slides. And
oh, I was hoping. Okay. Okay, thanks. Just joking. Okay.
Yeah, so this is, it is already a minute past the hour, so I guess we're going to start. This is a joint meeting between the routing area open meeting and the routing area working group. So that's what Chris was just talking about. We're going to spend the first hour in the routing area meeting, and the second hour, we are going to switch to RTGWG. So what's going to happen is this is being, I guess, hosted by the routing area. That's why you see us four at the top as chairs. And in the middle, we're just going to hand, not control, but I guess Chris and Jeff are going to lead the rest of the meeting in about an hour. John.
A request in the chat to switch to full screen on the slides.
Yep, I will in a second. Yeah, hold on. And of course, when I switch, I won't be able to see the queue, so you guys will handle that, of course. Let's do that. So I hope that's better. This is IETF 110, again, the routing area open meeting. That kind of moved weird. Hold on, I gotta change this so it doesn't move forward. Here we go. So this is probably the most ADs we've ever had at the same time sitting up front. This is Deborah's last meeting as AD, even though the official turnover was last night at the plenary, but we'll still have her here on the hook today. And this is John's first meeting as AD. Welcome, John. We're very happy to have you here. So this is not well. It applies to contributions. It applies to behavior that you have inside the IETF. So please read the BCPs at the bottom. We have been showing some extra links to the routing area wiki, the Directorate, for quite a while. We don't have any blue sheets anymore because they're automatically filled by Meet Echo. We're always open to getting feedback from any of you, either directly to us in the open meeting, privately on email, whatever you want. You can come to us individually as a group. You can give feedback about me, for example, to the other ADs or whatever you want. We're interested not just in our own individual performance, but also on how the area may be working better or could work better. What things could be enhanced, what can be changed, etc. This is probably the only, or one of the only ways we ever get feedback. The NomCom does give us feedback every year, but that is usually kind of sparse as well. A big part of our job as ADs is to review documents and take them through the process. Please please review the documents. We expect working group discussion, working group review, the chairs to participate. There are shepherds, directorates you can request early reviews from. Please review the documents so that we can increase the quality of the documents as they move through the process. So this is the agenda for today. Again, for the first hour. For the second hour, we'll head off to RTGAREA. We're going to go through the normal area status. Then we're going to have Luke talk about the routing directorate for a few slides. And then we're going to go into some working group updates. We decided instead of going through 3 minutes or a minute or every working group, we're going to give a little bit more time to, in this case, these 5 working groups. And they're going to spend, I don't know, maybe around 5 or 6 minutes each talking about their working group, what's interesting, etc. And then if we have time before the hour is over, we're going to go into open discussion or any other business that anyone may want to bring in. Does anyone want to change anything about the agenda? And by the way, I can't see the queue, so if anyone wants to, please let me know. Okay, so I guess we're good. So first, the most important thing, we want to thank Deborah for all her work. You see her here. You see her here smiling because she's, of course, off the hook of all the reviews and everything else. She has done a wonderful job over the last 6 years. I've had the pleasure of serving with her for that time. It's been a really great experience to get to know her, to get to share with her the good things about the routing area, and sometimes, you know, even the bad things as well. She has done an incredible amount of work, not just through the working groups that she has shepherded and been responsible for. She chartered DetNet, RAW. She led the standardization of the revised batch of Lisp drafts. There's been a ton of work that she's been doing with her working groups. Over the last 6 years, she has shepherded and published 144 different RFCs. These are RFCs are published, and there are over 20 more documents in the RFC editor's queue that all have been shepherded by her. This is an incredible amount of work that only someone who is, you know, very organized, very diligent, that is dedicated to the routing area can achieve. Deborah is only a great person. I think she is, or I know she is trusted and respected by her chairs, by her fellow ADs, by everyone in the area. And it goes beyond that with everyone in the AAG. She has been now selected to serve in the IAB. So we're going to keep seeing her around for a very long time. Thank you, Deborah, so much for dedicating so much time to the routing area. Now, before we all clap away, at least in the chat,
In the queue, and I think that we should listen to her talk.
Okay, so Deborah, are you going to say something? I also want to, I know Lou has something to say as well.
Alvaro, I'm not sure if you're waiting for me or not. This is Lou. I think you did a great job showing the appreciation from for us all. I really appreciate that. I talked with the other routing area working group chairs, and we wanted to do something to show our appreciation. And you can see Deborah is holding a little, it's like a little bit of an award that has inscribed on it that we are thanking her for her service or years of service, doing all those things that Alvaro said so eloquently. And we hope that it really serves as a token of the appreciation from your friends and colleagues in the routing area. We really appreciate all your help and oversight and guidance. It's been wonderful. We look forward, as I said in chat, we look forward to working with you on the IAD and maybe even again as a document author and contributor in one of our working groups. So thank you.
Again, Deborah, please go ahead.
Maybe a little help unmuting.
If you get your audio, there you go. Excellent.
I'm fine. There's a huge delay for some reason. Okay, I just basically wanted to say, and now I have a huge echo, but I wanted to thank all of you. Without all of you, nothing would have been possible. So thank you.
And Alvaro, I muted you to kill the echo, so please unmute yourself when you're ready to continue.
There we go. So I know we're all looking forward to the time when we can actually meet in person, have some beer, some wine, celebrate a little bit more the way that Deborah deserves. Thank you so much. Okay, so moving on. This is the working group status. We tried to put in here the changes since the last time we had a routing area meeting, which was a while ago. I think it was IETF 103. So apologies if we missed anything. So this was changes in the working groups. We closed one working group that actually happened today. So it still made it into the slides. I2RS was closed. This was the interface to the routing system working group. DetNet was rechartered, and RAW, these both are diverse or were diverse working groups, was chartered as a new working group. We also have a set of new chairs. Of course, Eve and Rick in the new RAW working group that has been working now for a while. Jeff and Kayer, who are taking over for John in IDR. And of course, the third chair is Suhair. Ronald in Manet. Dominique, who came a few ATFs ago to Roll, and Jim and Joel in spring last year. Thank you, all of you, for the service and for all the efforts that you guys put into making the working groups run. Martin?
You hear me?
Yep.
Yeah, okay. Just a single slide beyond pure working group status. Wanted to give you a heads up on two mailing lists, which are talking about topics that relate to routing area. One on application aware networking that you surely know because it's been around for some time, but still the list dates back August last year. And a much more recent one, Dincast, which talks about dynamic anycast. There was a side meeting yesterday, and I think all the actors of those two lists would appreciate more people joining and participating to the discussion. So that's why I'm giving you a heads up here. That's it. Handing it to you, back to you, Alvaro.
Great, thanks, Martin. So we've sent email to, I don't know, many of the aliases, I don't even remember which ones, about the new working group distributions. Now that John is taking over. So this is the new list. John is taking over most of what Deborah used to have, and we highlighted here in red the sort of exceptions. So he's also taking LSR that I used to have. I'm taking Lisp from Deborah and RTWG, and Martin got MPLS and PALS from Deborah as well. So this is the new distribution. So you know who to talk to if you need an AD, or as I said before, you can talk to any of us if you need to give feedback about us or the area in general. Okay, so we're going to go into the routing directory report. Luke, I'll hand it over to you.
Sure, Alvaro, thank you. So I'm just going to present, I think, 2 or 3 slides, just a quick overview of the routing directorate role. So on the next slide, you'll see basically the directorate consists of approximately 40 to 50 routing area experts. So these experts are appointed by the ADs to help and basically perform routing area reviews of drafts that are going through typically through IETF last call, but also these experts sort of jump in and provide routing expertise to other areas on routing related drafts, and occasionally also provide basically early reviews of routing area working group documents even before the working group last call. So in essence, the goal of this directorate really, or these reviews within the directorate, is to encourage cross-pollination of routing knowledge and expertise across all the working group in the routing area. So on the next, so there's a quick link to the wiki here of the, I think the 44 experts, the 44 currently are listed on this wiki. On the next slide, Alvaro. So we compiled, actually AD compiled a few statistics of the work done on these reviews. So obviously stats always speak for themselves, or rather you can make them say what you want them to say. But I think what's worth highlighting here is, first of all, the sort of increase or the pickup of reviews in these last 3 virtual IETFs. So there was a bit of a slowdown as people were trying to figure stuff out. But other than that, what's important to highlight on the right is, I think the blue portion of the horizontal graph bar is important here. So these represents early review of drafts. So these are drafts that are not even at last call in their respective working groups. And what you'll see is that only really 4 or 5 working groups take advantage of this tool that's being offered to them. Next slide. So this slide, I think, really highlights the value add of these routing area reviews, especially on the right. You'll see that 61% of these non-area reviews come back with have issues. And sort of to sum up, I think that shows the merit of these reviews, since the goal, the end goal really is to improve document quality. So I would encourage really everybody and the chairs to keep calling these early reviews. I know it's a heavy workload on the, I guess, the voluntold experts by the area chairs, but they do have a definite benefit. Thanks, Alvaro.
Thank you, Luke. Anyone have any questions? Okay, so yes, definitely. Thank you so much to everyone who serves in the routing directorate. All the reviews that you make help definitely increase the quality of the documents as they go through. So as I mentioned before, we're going to go through some working group updates. We asked 5 different working groups this time to provide a short update. A little bit more than just the litany of drafts that are being talked about, but not too much just to go into a deep dive of what they're talking in their respective working groups. So we're going to start with DetNet.
Hi, this is Lou Berger, speaking for DetNet. Janos Varkas is here, and we do have a tech advisor from the TSV area that's a little unique or unusual. I'll talk about that briefly in a moment. Also, we have a secretary, so we have a lot of people involved in the working group. Next. Good to hear that. Good to know that I'm being heard. So DetNet is about providing deterministic services over closed administrative groups or cooperating administrative groups. Its scope is not the wild internet, but we do worry about providing services over different technologies. This sort of gives you a map of the technologies we support. So we can do straight IP over MPLS, straight MPLS, MPLS over IP. We are worried about time-sensitive network that's coming to us from the IEEE, so we can actually sort of do an Ethernet VPN. So think of that as an enhanced EVPN over MPLS, and we can also use TSN as a sublayer. So there's a lot of mixing and matching, a lot of combinations. Each of the red items shows an actual draft, although those are we've published our first set of documents, so some of those are now RFCs, and we have finished our core set of data plane documents, and most of the rest of those are in the RFC. So this gives you a map of where our technology is. One of the key things is we are operating on existing data headers. We haven't defined anything new, although we are using what we call a DetNet control word, which is sort of the other control words that you'll see in use with MPLS. And I think we're going to be talking about it a little more tomorrow with a nice joint group with pals that they'll talk about. Next. So that looked like a lot of work done, which is great. And so what are we doing next? We do have an informational document talking about queuing implications. There's been some discussion about maybe us doing more than that. We are wrapping up our management model, our Yang model, that covers everything but the TSN part that you saw on the previous slide. And that's why that previous slide, TSN, was marked as future. So that's also a really important Yang model from our standpoint. And we're working currently on OAM and control plane or controller plane. So one of the things with DetNet is we want to work either with a fully distributed control plane or a centralized one. And to sort of say we don't care, we came up with a new term called controller plane, which is a superset. Maybe that was a good idea, maybe not, time will tell. But when you see controller plane, it's not a typo. We actually mean that it can be either a fully centralized, fully distributed, any combination of those. Next. So we thought that it would be worthwhile pointing out in this group that we do an awful lot of coordination in DetNet with other groups. You saw the technologies we're involved with. I don't know, chairs, if you want, I'll spend a couple minutes on each of those, but I think I've been talking my 5 minutes. Do you want me to keep going, or do you want me to stop?
Sure, I think we're okay. I think we're running a couple minutes early, actually. So
okay, great. So let's keep going. So we'll talk about some the ones that we identified we thought would be interesting. Next slide, please. So the raw group is really a group that we're closely cooperating with, because their scope is, and you're going to hear about them, is to work with DetNet over wireless technologies. Strictly speaking, our charter allowed for work on wireless technologies, but we thought it would be really good if there was a place that had that focus, and in particular brought in new blood. So we are worrying about the overall data plane, as well as adapting to wired data planes. And in the wireless space, we're working closely with the raw working group. We're meeting with them about every other week. Next. Spring is interesting. You'll notice that in the document list that we had, we talked about running over TSN, MPLS, IP, but we didn't call out SR. And we've had a number of documents that have said, let's do DetNet over SR. And those documents have shown up typically in both working groups. And we've been trying to coordinate with those chairs on which draft should go where. And we sort of have a working proposal. It's not finalized, but that if we're using existing SR formats, they're going to end up in DetNet. If it has any type of new format, that'll go to Spring. Next. I mentioned before that we are lucky enough to have a transport area advisor, technical advisor. This was something that was supported, proposed by the TSV AD a while back, and we weren't quite sure how good an idea it was, but it's turned out to be excellent. And what it's meant that as we are progressing our documents and looking at the different issues, we have someone in the room who can provide us really good feedback from the TSV perspective to make sure that what we're doing is going to be aligned with the sort of the normal IP diff-serve considerations, and having this early and often allowed us to get through the ISG review, I think, in a fairly good way. And of course, that was because we had addressed the issues. So that was really great. We have had one question recently about new queuing mechanisms. There have been some proposals to do completely new queuing algorithms, queuing mechanisms on the device level. To date, DetNet has said we will talk about other queuing mechanisms that are standardized elsewhere and how you might use them for DetNet, but we're not defining queuing mechanisms. And to my knowledge, the routing area has never defined queuing mechanisms. So it's certainly out of our charter to do that. But there's a question of where should this be done. The TSV working group, in particular, David has made comments publicly that if it is a new queuing mechanism where it's only DetNet specific, maybe TSV isn't quite the right area to do it, and it might be better to do it in DetNet. So we have an open question. Really, it's going to end up to the ADs to sort of make a decision on where this work should be done. So that's an open question that I don't expect us to discuss it today, but I do expect that we'll see an answer on this in hopefully not too long. Next. I see Torlis is in queue. Chairs, you want me to take?
Yeah, I was just about to ask if you want to take questions as they come, or if you want to hold.
I'm happy. It's your time.
I'd say let's do it as they come, Torlis.
Yeah, I just wanted to
back one slide,
that, I think one of the biggest achievement in DetNet, at least from me kind of looking at use cases, is the pre-auth, which is kind of the also what I would consider more like a transport QS function to eliminate duplicate packets with sequence number. Something sequence number we also I don't think had that much in the routing area. So I think wherever it falls, I don't see the queuing to be particularly different from the work that was done in pre-auth.
So that's a good point. If we back on that first slide, we talked about the DetNet control word. We use the standard DetNet control word, including the sequence numbers that were previously defined in the DetNet control word. In the standard control word that was used both in PALS and in EVPN. We use it to provide basically 1+1 protection. For those of you who've been active in sort of the more transport-centric areas of the routing area, you'll be familiar that we've done 1+1 protection for various technologies in the past. DetNet defines it for today for MPLS and using those sequence numbers, and maybe in the future for IP as well. Thanks for the comment, Charles. Dean?
This is
Or Dan?
relevant to
Sorry.
that same topic.
On the TSN. So that's the reason why I just joined the queue. I'm happy to give my comment after you do the TSN part.
Oh, okay, great, thanks. Thought it'd be worth mentioning the TSN group in particular. So time-sensitive networking is a activity it's a task group inside the IEEE. We're really fortunate to have great cooperation between the IETF and IEEE on this. My co-chair, Janusz Farkas, is both DetNet Working Group co-chair and TSN Task Group chair. So by having the people actively contributing in both groups, we've really been able to have great alignment there. Of course, we also have the IAB's activity of IEEE coordination, so we have both at the formal level and the informal level, and it's been really great. We held one workshop in Bangkok in 2018. We had planned to do another joint workshop in 2020, but obviously that was canceled, and we hope to do it again in the future. TSN is an important technology. It's an underlay technology which gives us a lot of queuing mechanisms that we can reference. It is not a requirement, though, for DetNet. DetNet is designed to operate over any type of, let's call it subnet layer. Dan?
I wanted to ask if I've seen several comments between TSN and PTP, and in some of the implementations, there were some issues. There were some. There are some unknowns between one and the others. So, have you had any touches with the IEEE 1588 group on the same topic?
So we had discussions on this early on that, would we need to specifically describe time synchronization in DetNet? And I think you'll see some of that in our use cases and maybe some of our early documents. But as we went on, we concluded that that is typically sort of a layer below the routing layer. And if you're talking about time synchronization across a device, that usually happens sort of at the hardware level, and that we didn't have to do anything specific for it. So that hasn't been an area where we spent a lot of attention recently, and it's not at all in our data plane definitions. As you know, there's some good profiles talking about, and I can't remember if it was ITU or IEEE that had the profiles of different types of devices. We would hope that a profile would be written for a router that's DetNet aware, but we didn't see that as in our scope. That said, we are contribution driven. So if you think there's something we're missing at the DetNet level, please bring it to the working group.
Yeah, okay. I'll definitely. I think I see a few of them based on the customer conversations. Thank you.
I think that was my last slide, but just next, just in case. Yep. Thank you so much.
Thank you, Lou. On to Ra.
Hello. Hi, can you hear me? This is Eve Schuler. And I'm one of the co-chairs of RAW. And unfortunately, my co-chair, Rick Taylor, is chairing another session at this exact time. So he sends his regrets. As Lou said, we are, next slide. We are a sister group to DetNet. We're about a year old. And the intent was to ensure that we could extend DetNet to comprehend wireless layer 2 technologies. And what we mean by that is to support these deterministic properties, mostly around bounded latency, packet loss or packet errors, and consecutive errors across L2 bridged and L3 routed segments. And although the DetNet charter does talk about heterogeneous support because of all of the layer 3 technologies, the intent here was to ensure also seamless operation across wired and wireless subnets. So that is our focus, is really on what is the relationship between layer 2 and layer 3 to support the wireless. Obviously, as you get into wireless, to claim that something's deterministic becomes increasingly difficult because of all sorts of issues, not least of which is interference. So how do we make the wireless technologies highly reliable and available and approximate determinism, even if we can't give as strong assurances as our wired counterparts? So the 4 technologies that are in charter are basically Wi-Fi 6 and beyond, the time-slotted channel hopping IEEE 802.15.4 standard, which in the IETF has been known as 6TISH as a working group name. Obviously, there's tremendous focus on 5G support in at least the part of the discussion around ultra-reliable low-latency communication, or URLLC. And a 4th technology, which doesn't get as much airtime, so to speak, which is the L-band digital aeronautical communication systems, known as LDACs, which is ground-to-air and air-to-air communication. And so, this is something that is our 4th technology of consideration. We do work very closely with DetNet. This was spun out to try to attract some of the wireless experts that might not show up to DetNet, given its name, and that this really very specifically focuses on wireless. But we, as Lou indicated, we meet very regularly. We meet regularly between co-chairs. The participants in both the groups, tremendous crossover, and we're even coordinating on documents to ensure that we have consistency, for example, for some of the newly arrived OAM documents between the groups. Next slide. You've seen this this picture, but to remind you that our relationship is to be considered just another technology alongside of Ethernet to enable some of these technologies. For example, work with the TSN shim that was alluded to in the previous report out. Others not so much, but potentially in the future. So there is this nice layering of and concern about how does the layer 2 technologies and the layer 3 technologies cooperate to deliver determinism. Next slide. When we were launched, which predates me, we had this ambitious goal. The charter had an ambitious goal to more or less support for foundational informational documents, and to do so in about 18 months. We've been around for about a year now, since the last time the routing area supported an open work group meeting. And what I will point out here is that 3 of these documents, foundational documents, were all about, meant to be sort of foundational, and a 4th was, and still, which is really the thing that's mostly in our long-term, something that we have not started as yet, is to really evaluate the existing IETF technologies and the gap analysis. You'll see in the upcoming slide that we're just beginning to get into that stage, and we have spent the last year really trying to figure out our foundational documents and what is the storyline. Next slide. I stated in that fashion because if you look at how DetNet has unfolded, it did a great job. It spent a long time kind of getting its foundational what are now RFCs correct in order that it sort of accelerated into producing really the specifications that are RFCs now. And so we wanted to really mimic that behavior, and we have focused on whereas DetNet had a problem statement, use cases, and architecture draft, we've started out as well with a use cases document where we've highlighted all the scenarios that might require a raw approach, reliable, available wireless, the attendant technologies, the 4 technologies that contribute to the discussion, and get ourselves to some kind of architectural position statement or framework document. And so we've spent quite a bit of time, and I should say that there were several BOFs before the year. This just didn't come out of nowhere, as many of you know. Pascal had been working in this area for quite a long time under the auspices of DetNet, and so we had quite a few documents ready for discussion and consideration. So our use cases doc is just like the DetNet doc. It's fairly high level, and it has fairly high level requirements. Our technologies doc has done a great job to articulate the concerns of each of the 4 technologies under consideration. And unfortunately, and I think this is in part, some of the, I'll call it, there's a little bit of an allergic reaction to documents that are, position statements or some of the informational information that's needed to set the stage. So there was some concern around articulating a problem statement, but each of our drafts now already include a problem statement. And so we're likely to extract it and, after all, have a problem statement draft. And we're at a point where our architecture, we're rejiggering our architecture and framework documents to go from sort of a specific, to go from these, what we'd really like is have an architecture document that's very generic, and then framework documents that are more specific to the technologies. Next slide. In addition to our foundational documents, we have begun to have some really interesting conversations about the glue between different technologies that already exist that would help us coordinate between layers. DLEP being one of those technologies that's already in RFC, the dynamic link exchange protocol, and it has some efficient characteristics in that it's an event-driven protocol, so less overhead, that would monitor layer 2 link characteristics, but also expose them and share them with layer 3. And this is really the beginnings of that elusive 4th foundational document around how do we get to our gaps analysis. So this is, we've had some early discussions around DLEP at this IETF. We now have an OAM draft that has been separated into its requisite parts, that one in DetNet and RON, they're both nearing working group adoption. And our LDAX draft, which was adopted by the working group, is likely going into working group last call. And we have had some new topic areas introduced. As you can imagine, the reliable and available wireless is really important in industrial systems and in industrial IoT. And there has been a terrific new document that has upped the bar on how much detail we need for requirements in that area. And additionally, some metrics that would help us understand operationally the various kinds of scenarios faced in industrial systems. And I know that this, the explicit ask for these presentations was, how are we coordinating with other groups? And there are a series of MEC drafts, and MEC is an ETSI driven initiative around mobile edge computing, and so we've begun that discussion there. We'll see where that leads. And additionally, although it was not presented in our working group at this IETF, there was this segment routing inspired TSN draft that did get airtime in DetNet and other working groups at this IETF, which we anticipate will, at least in some regards, get folded into our, if not discussions, then our milestones, or at least for consideration. And I think that, oh, maybe next slide, the next slide is a summary of everything I've said on this slide, which is really where our documents are. We finally have one working group last call, a couple nearing working group last call, all of our, our foundational docs. And so this is just the pointers to those resources. Next slide. And for further information.
Great, thank you, Eve. Any questions from anyone?
Thank you.
Right. So this is Stuart, and I'm going to talk about some work that we're doing in PALS, an issue that arose from PALS. So next slide, please. So PALS is holding a meeting on Friday at 12 o'clock UTC jointly with DetNet, MPLS and Spring to discuss a number of recent proposed changes to the MPLS architecture. There have recently been a cluster of proposed MPLS changes. There have been a number of proposals to add metadata after the stack. There's a proposal to add metadata in the stack. There have been a number of proposals to create new extended special purpose labels, or even, I'm not sure, in some cases to use a real reserve label, real special purpose label. And there's also been a rather interesting proposal to repurpose some of the special purpose label bits. Next slide, please. So why PALS? Why did PALS of the cluster? Why did PALS pick this up? Well, we were the first working group to deploy metadata below the bottom of stack, the pseudo-wire control word. So we noticed it. DetNet copied the approach that we used, and there's commonality in the two designs. In both cases, there's only a single control word below the stack. There are some new proposals that would require more than one set of metadata below the bottom of stack, and this leads to potential complications. So what we feel we need to do is to make sure that the addition of other metadata does not break or change any of the existing protocols. Or if it does, we need to know how the behavior changes, what the consequences are, what the costs are, and what the mitigations are. So next slide, please. So why do we raise this, right? None of the proposed changes themselves are large or significant. However, in combination, the result is complexity. The result is a change in the MPLS forwarding model, a very simple model so far that we would reluctantly see increase significantly in complexity. And of course, if these changes, which are simple in themselves or in combinations, if we get it wrong, then they may fundamentally limit MPLS development in the future. So this is all about going into this with an open mind, but nonetheless understanding what the consequences of what we do are. So the plan is to get the interested parties together on Friday to do three things. One, to understand the needs that underpin the various proposals that have come together in this cluster. To understand the proposals themselves, or understand some of the proposals themselves. I'm not sure we've unearthed all of them yet. And to develop a way forward that deliberately changes the MPLS architecture to a model that meets the new needs. We don't want the protocol to stall or become ossified. So it needs to meet future needs. But we don't want to discover that in meeting the short-term needs, we have boxed ourselves into a corner as a result of a set of uncoordinated changes. So it's about bringing all the interested parties together, understanding what the new needs are, understanding the various proposals, and then formulating a way forward. We won't do all of that by any means in the 2 hours we've got on Friday, but we can start this process and then discuss with the ADs and other chairs how we would go forward afterwards. And I think that's my last slide.
Thank you, Stuart. Any questions? If not, this is tomorrow at noon time UTC. Thank you so much. On to Spring.
Hello, Bruno speaking. Next slide, please. So I'm going to talk about Spring. Do you hear me?
Yes, we do.
Okay. So what is Spring? Spring stands for Source Packet Routing in Networking, and is better known for being the home of segment routing. The three main pieces of work we have done so far is segment routing architecture that we published in July 2018. Then we have two data planes. First is the segment routing MPLS data plane, published in December 2019. And then the segment routing for IPv6 data plane consists in two documents. First, the IPv6 packet extension, segment routing header extension, published in March 2020. So the work has been done in 6 months. And then the SRv6 network programming, published in February 2021, so a few weeks ago. Next slide, please. So that being done, the current hot topic is to try to work on reducing the size of the IP packet header for SR over IPv6. So what we have today is SRv6 use segment identifier using 128 bits addresses. For many use cases, we only need a few segments. But as the number of segments increase, the size of the header increase, which involves hardware challenges and traffic overhead. So far we have multiple individual solutions being proposed to so-called compress the header. What we really mean is to use smaller segment identifiers. And each solution is proposing to define extension in different working groups, such as 6man, LSR, IDR, Spring, and PCE. So far, we could not have natural convergence. So we have very different starting positions. So some people believing that we should start with SRv6 and try to minimize the evolutions. And some people believe we should try to start with SR-MPLS over IPv6 and minimize the evolution. And some people believe we should start with a new design, with a new IPv6 header or headers. And we have strong positions. Next slide, please. So we've created a design team in June 2020. It is tasked to create or produce two documents. One is a list of requirements for the solution or solutions. And second, a document comparing the different solutions, and in particular against the requirements. So we have a very good involvement from the design team, a lot of work. Yet the planning currently exceeds the original plan time frame. Latest status in this IETF, the design team reported to 6-man and Spring working groups. They publish an update of the requirement document, version 05. So published, presented, and they have just asked for adoption, working group adoption. And they also present the first version of the analysis document. So it has been published and presented. So far, it is very preliminary. So no, I would say no detailed analysis. And the rough plan for the design team is to complete the analysis by late May. By complete analysis, I guess it's a complete first version of the analysis as a feedback for the working group. Next one, please. Another significant topic is the SR policy architecture. It's a big part of the segment routing architecture. It is being referenced by 96 documents, out of them 37 being normative. So most notably, sorry, it is being referenced by 10 IDR working group documents, 4 PC working group documents, 2 MPLS working group documents, and 2 TEAS working group documents. And it will be last call soon. Should be in a couple of weeks, a priori. Next one, I believe, is the last one. Next slide, please. And finally, a recent subject regarding the interconnection of domains with multiple planes. So in this subject, each domain may have multiple planes, I mean IGP planes or planes within the domain, to enforce multiple objectives. Typical goals would be to have one plane for shortest path, another one for lowest delay, another could be only high bandwidth links, another could be not routed over via whatever you want or don't want. Each domain may use any choice for its local enforcement of the plane. So typically, it could be SR policies, or SR flex algo, or RZPTE. So the question is for service spanning multiple domains. There is a need to build coherent inter-domain routes sticking to each plane within each domain. So in IETF 110, so this one, we have seen presentations in Spring, IDR, and base working groups. We have a set of documents about use cases, requirements, architecture, and extension. And we have two sets of two solutions with two sets of documents. So for example, in Spring today, we had those two documents presented. So that's all. That's all for Spring.
Thank you, Bruno. Are there any questions? Okay, so I guess we're on to the last part.
This is Tariq. I'm going to give you the update on the MPLS working group status. Can I go ahead?
Yes, please go.
Okay, thank you. Just a quick note before I start talking. The update is on the behalf of my co-chairs as well, and we have a Secretary Mac Chan as well in our working group. Let me just mention that Stuart has done a great job setting the stage, describing the problems of mutual interest between MPLS and PALS. I will go through a couple of them as well. It might sound repetitive. Nevertheless, some of the topics that the working group is paying special interest in are starting with special requests for allocations of this scarce resource we have. It's called the special purpose label space, and new applications are popping up and asking for new allocations. We're trying to manage these requests and then choosing should it be in the extended special purpose label space, or does it necessitate the very scarce label space of the special purpose label. There are also multiple proposals to embed identifiers within the packet to distinguish for specific purposes, there's network slicing or for path identification. For example, in segment routing, there is a need for identifying packets belonging to a specific path. There are other instances as well that identifiers are needed, and at least we have 3 proposals. 3 drafts were presented early on Monday, and we're going to have to agree on a proposal to move forward with. So some of them are proposing that the identifiers be in the label stack, within the MPLS label stack. Some of them are proposing that the identifiers sit after the end of stack or the bottom of the stack. There are proposals also in MPLS working group to repurpose. Actually, no, I jumped one bullet here, is to use a special purpose label to alert the transit LSRs of the presence of metadata after the bottom of stack. So again, we are trying to see if there is a chance for generalizing this kind of alert mechanism rather than giving for every request a new special purpose label. Lastly, there is a request that we extend or enhance the purpose of existing special purpose labels that are already allocated, and there is hardware support for them, possibly to reuse them for new applications. I do mention 2 of them, the generic associated channel label, the GAL, and the entropy label indicator. These are already allocated reserved labels. There are proposals to piggyback on those or enhance the capability they can provide by carrying additional information. Next slide, please. So it was mentioned earlier that there is a joint meeting happening on Friday, session 1. The focus of this meeting is to ensure that any extensions in MPLS working group do not conflict with the existing features supported by PALS, as was mentioned by Stuart. We need to understand the new requirements. So the new requirements popping up from network slicing and other things I mentioned will be discussed, and then we will try to agree on a way to move forward in such a way that we don't limit ourselves, as Stuart mentioned as well, and be backward compatible. I apologize, I don't have too many colorful slides, and I did compose 2 slides only, and this is my last slide. But there will be an interesting discussion tomorrow, I promise you, in the morning session. So I do encourage everybody to join if they can. Thank you.
Thank you, Tarek. So unless there are any questions, we're on to our last slide, but we're time. So I guess what I want to do is finish the routing area part of the meeting and hand over presentation to RTWG.
Okay, thank you. I will try to share the slides for the RTGWG meeting.
Something is coming up.
Okay, good, good. Let's see how this works.
So before we start, we will do chair's bashing and everything else during tomorrow's meeting. Today we go directly into presentation mode.
Correct. I have the agenda for today here, and we're going to do the status update in tomorrow's meeting. So for today, we have first presentation is from Adrian Farrell about sort of a request for help working on some work on address semantics in the IETF, and then Shupeng talking about presenting and trying to have some discussion about application and aware networking. So we'll start with Adrian's presentation, and hopefully I can go to full screen mode here.
Yeah, looks good. Not anymore.
We'll see till it settles down. Okay, finally settled down in a good state, I think.
Good job.
Kind of.
Okay, thanks for time on this agenda. I don't want to take up too much time, but just a quick couple of minutes to flag up some work we're doing to investigate research related to the idea of changing or adding to the semantics of an IP address. We wrote a draft in a bit of a rush. We actually managed to get 2 versions out before the cutoff date, but it was more words than we really could fit in the time. So it's a bit rough, and we're working on an update and restructuring it to make it readable and meaningful. And although we targeted this at the IETF because it's really a research project, it's obviously central to the routing area. Thanks to those who've already commented on the routing discussion list, those who sent private notes, and a few of you that we've discussed in a bit more depth with over the last couple of weeks. So what I want to do is quickly paint a picture of what we're looking at and tell you what we'd like from you, and hopefully attract your attention to discuss this a bit further. Slide, please. So this is all evolving rather rapidly as we discuss, but what we're trying to do basically is understand the implications for the routing system of this thing we're calling semantic routing. And we're doing this by trying to catalog the existing proposals and existing research, and then formulate a list of questions that maybe researchers should be looking at. What we're not trying to do is claim any support for any of these proposals, and we're certainly not trying to come up with routing protocol solutions at this point in time. So what do we mean by semantic routing? Slide. Largely speaking, we're talking about routing on additional information. So we've done this for forever, and really the prehistory of routing purely on a destination IP address has long passed us by. We've been considering a number of things inside the network to help steer packets, and whether we've called that preferential routing or policy-based routing or flow steering or whatever. Next slide. So there's a number of proposals kicking around that talk about encoding additional information into an IP address. That's to say, giving enhanced meaning to some of the bits of an IP address. Quite often these proposals limit the scope of applicability. They talk about a domain of use, and outside that domain, everything is just an IP address. Inside the domain, some of the bits have special meaning. And to some extent, this is not new. So if you look at the way that prefixes have been partitioned so that certain addresses have special meanings, that is, in a way, a semantic addressing thing. But question, is that all there is, or is there more? Next slide. So more recent proposals have done other things, and a very good example is the recently published 8986 for SRv6 network programming. We've seen proposals to address service functions directly with IPv6 addresses in service function training, and there's discussion around a form of ICN that gives meaning to the address to address content. There's also a lot of discussion going on at the moment about variable flexible address lengths, which might be useful in constrained environments. There's been for a long time, I think, discussion about could we scope addresses hierarchically and therefore make simpler multi-domain routing. And I think the latest incarnation of this I saw was for satellite routing. And then there's discussion of encoding additional information into some bits of an address in a way which is a bit similar to SRv6 network programming, but it's just applied to a flat address with no concept of SR going on. Next slide. So, whoop, missed one, that one. Semantic routing then is routing on addresses that have got this additional semantic inside them, with probably the intention that legacy nodes will survive the fact that the addresses are semantic addresses, but that new or enhanced nodes may be able to get additional routing function by looking at these addresses. So on the left here, I think the bottom is being cut off, but the left is prior art, and it's showing how a routing decision is basically made on an IP address, a pile of other information perhaps, and some policy and configuration that's been put into the router. And then on the right-hand side is routing with semantic addresses, where the other information, that middle box, may still be feeding into the routing decision, but mainly it's being placed into the IP address so that the routing decision is based on that address without having to trudge through the other fields in the header and maybe doing DPI and so on and so on. So next slide. So this is definitely a work in progress. We scratched together some questions we think that need to be looked at when considering semantic routing, and they include, will this break the existing system, and will we need new software, new hardware? Can we actually handle this type of processing in hardware? Does it scale? do the claims that it helps scaling actually hold up, or does it make things worse? Will more addresses need to be pushed into the network? Does it break existing additional functions like multicast? And bottom of that list is do we actually need to standardize anything, or is this tucked away in private domains that can just do what they want beneath a routable prefix? Next slide. So what do we want from you? We're at the moment at a stage which you might call a literature review. So we would love to hear pointers to relevant work. And a lot of you have been doing that already for us. Thank you. But I'm sure that there's research work out there that you know about. Suggestions for additional research questions, because that list which appears in the draft is a little bit thin and probably not very well focused. But we're really looking at what could go wrong with routing, what problems should people be researching, how should they be going about that, what type of network should they experiment with. And that at the moment we're not sure, but we think that there's not a lot of IP routing research going on. There's quite a bit of work on overlays, but we're not finding much on routing. Possibly it's really well hidden. Maybe this is because the RRG was shut so long ago, or maybe routing is complete and everything's been done and we can go home. And of course, possibly it's because of funding issues and so forth. So we'd love to discuss. I don't know whether the chairs want to take questions and discussion now, but obviously you can email us, you can mail on IRTF Discuss, and probably the ADs won't mind if we continue a bit on routing discussion, as has happened before. So thank you.
Okay, I think we're fine with taking a few questions. I think Linda has raised her hand.
Presentation. So I'm curious, the semantic address, is it still IPv4 v6 or something different? Now there's IPv, what is that? Another 6J IP addresses. So what it is?
So what we're seeing is suggestions to impose semantics on chiefly IPv6 addresses. We would be interested to hear that, no, this really needs to be off in a whole new address space that might run ships in the night, or in a brand new internet. But I'm not sure that my focus, anyway, is beyond what would happen to IP routing, and that's basically IPv6 routing, if this semantic addressing goes ahead.
And second question, what kind of semantics do you plan to add to it? Is there any example?
Okay, so that's back to the slide that says we don't support any particular ideas for semantic addressing. We are just collecting proposals. So other people have lots of proposals. That's great, but we want to research around those rather than push any individual proposal.
Okay. Thank you.
Okay, thank you, Adrian.
Okay.
Now we'll switch over to Shupeng. Let's see if I can just switch over to this presentation. There we go. I think, so you can go ahead and unmute yourself, hopefully, yeah?
Hi, thank you.
Okay, well, you're welcome.
Good. Hi, this is Shuping. I'm going to present APN, the Application Aware Networking. Next, please. First, about the purpose of this presentation here. Actually, we believe APN is most relevant to RTG area. And we have presented a few times here. And we have involved RTG in most of the APN discussions in the mailing list, APN mailing list. We can see the progress has been made. And here, we would like to further introduce the concepts, clarify the scope, and attract people's attention to further address the main concerns raised by the IESC and to make the work to progress further. And I will keep this presentation short and leave more time for discussions here. Next slide, please. So I will follow what, why, and how this logic to give this presentation. And thanks to our AD who gave this suggestion. And first, so what is APN? And APN is on that network layer. And we want to enable the fine-grained user group, application group, and service level requirements guarantee at the network layer. And in order to do that, we will develop a framework and set of mechanisms to derive, convey, and use an attribute. And this attribute information is the key. And it will be encapsulated in the data packets. It will be treated as an object in the network. And to this, the network operator can apply policies in the various nodes and service functions along the path. And here, which is very important to note that APN works within a limited trusted domain. And this domain is generally defined as a service operator's limited domain. And within this domain, the operators could support and could use their technologies to provide the services. And as shown in this diagram, it's very simple. And the APN attribute is tagged or removed at the edge of this limited domain. So that means once the packets leave this domain, it will be removed. That won't cause any impact to the rest of the internet. Next slide, please. So what is equally important is what APN is not. So APN is not about identifying the particular application or the users to the network or within the network. The network doesn't even need to know this information. And to know this information, it will also break privacy, and we are aware of that. So it's all about policy enforcement in the network. And also APN is not pan-RG, which is the pan-RG is make the application aware of the network, but we are the other way around. We want to make the network aware of the application or user's requirement. So APN is not SPAD and plus, which carries the application information in the transport layer, but we use the network layer. So APN is not network tokens, which is a tag, which is tagging the tokens at the host or applications. But we tag the attribute as the network edge device. So at the end, this is also the conclusion we derived from one of the SAT meetings at IETF 108. That is to convey information at the different layers of different technologies. And APN uses the network layer. Next slide, please. So here, why APN? We use a very concrete but simple use case that's about SD-WAN. So in the case of SD-WAN, network operators can provide SLA guaranteed WAN lines to enable the enterprise to access the clouds. So when we map the one line into the operator's network, so usually you will find multiple network paths available, but they are with different SLA guarantees. And currently in the IETF 70, there have already been a list of match items which are published. And use these match items, the edge device, so here is CPE node, could steer the traffic into the corresponding WAN lines. And for example, the match items could be 5 tuples. But still, there is a need to communicate user applications requirements to the network to match to the capabilities of the WAN line. Because once the traffic goes into the network, there is still a need to apply various policies in the different nodes or service functions along the path to this traffic flow. So for example, at the head end, we need to steer into the corresponding path and which can satisfy the SLA requirements. At the midpoint, we need to collect the performance data, measurement data, and also do some visualization. And as the service function, we could use it to, we would need to execute particular policies. Next slides, please. So we will see that currently there is still no effective way to do this. So probably that would be possible to stack those various policies in a list of TRVs in the header of each packet. But you can imagine the big challenges that is going to be imposed on the hardware processing and forwarding. And also, when we do the policy-based routing along the path, so normally people will use ACL via the 5 tuples. But in some cases, it's very complicated to resolve these 5 tuples. So for example, with the tunnel encapsulation, it's very hard to resolve it. And because the transport layer information is just pushed very down and it's very hard to gather. And with IPsec, so it's not possible to obtain any transport layer information. And in the IPv6 data plane, with extension headers, so we know there are a list of the extension headers being added. So the transport layer is pushed very down and very deep. So sometimes it's not possible to have these 5 tuples within the network. So next, please. So how we can solve the issues? And we did some gap analysis. There are some possible solutions. And here is a possible solution, what we propose. And we propose to construct an attribute at the network edge and encapsulate in the data packet and treat it as an object in the network. And to this, the network operators applies the policies and provide services in the various places along the path. So, and the policy choice is according to the user application group and service level requirements. So in this way, it could bring several benefits. For example, it will improve the forwarding performance. Since before you need to resolve the 5 tuples in the different layers in the packet header, but now you only need to look at the one field in the IP layer, which will also improve the scalability. And also it will enable the very flexible policy enforcement in the various nodes and service functions. And also it could enable more new services. For example, with SFC, and you don't need to resolve the 5 tuples to do the policy enforcement on the VAS, but only one field. And also, it could enable the fine granularity performance management and visualization. And also, it's not only about underlay, it could also work for the overlay. So we can see that can be easily done by using this information, but it's impossible with any of the current existing mechanisms. So next, please.
I'm going to take a moment to switch to full screen mode. Since this takes a couple of seconds, I didn't want to do it in the middle of your presentation. So just hopefully this will, will be better. Okay.
Yeah, sure.
So
Thank
now,
you.
You're welcome. So, okay.
Okay, so we did some gap analysis, and there are some work in IETF already. First, about DSCP, but we know it's not big enough. And then for the IPv6 flow label, or MPLS entropy label, it has been standardized to be used for the ECMP. And for the SFC service ID, that is defined to be used in the NSH context header, but APN attribute can be carried in the various data plane that is decoupled from data plane. And for the IOM flow ID, that is used to correlate the exported data of the same flow from the multiple nodes. And for the banding seed, that is bound to the SR policy, but APN is not bound to SR6 only. And the flow spec label, that is bound to MPLS, but APN is not. Next slide, please. And so we can see that the existing solutions are specific to a particular scenario or data plane. They are not the same as APN. And so they are unable to achieve the same effects. And also driven by the new services, the fine granularity service provisioning becomes also urgent. So APN aims to define a generalized attribute used for service provisioning within the network and can be carried in the various data plane. Thank you. Next, please. Oh, yes. So here, during this week, we have presented in the art and also the security area. And that was very good, thanks to all the ADs and the chairs. And we have collected a very valuable feedback and have a lot of very good discussions with the experts there. And interestingly, we found people have been frequently asking some similar questions. So that's why here we summarize a list of the FAQ and just to try to make the clarification on people's concern. And first, so people asked whether there are any applications that can benefit from APN. And to me, that is a very easy question. And so if I may, I would like to ask, have you ever experienced any mid-echo issues during this IETF and any virtual ones before? I would say that is the one of the exact application that can benefit from APN. And also in this IETF, we had a hackathon application of our GSR-resist networking that shows the improvements that can be achieved with APN. And we have also published 2 papers in InfoComm this year and last year, and both in the demo session. And we have demonstrated the improvements that APN could achieve. So here are some links for your reference. So second, how APN can help resolve the QoE issues. So when you go into the details, you could see, and from the demonstrations, you could see the difference of improvements that APN can make within the network. And regarding the QoE, that is very complex. and itself has many impacting factors, including the terminals, access, and also the network. So APN aims to provide ways to improve the QoE within the network. And then who is going to set the APN attribute? So that is the network edge device, such as the CPE. And it's not the application itself. And then how to set the APN attribute? There are many possible ways that can be used to classify the traffic flows at the network edge. And for example, the n-tuples defined in the IETF110 and maybe AI technologies. So the APN attribute can be derived by using those already published match items in IETF110, as well as, for example, the access port in the edge device, and to identify the user group. And then how the APN attribute is used in the network. And I already presented here very quickly. So this attribute is carried in the data packets header, and it can be used in the various places along the path. For example, at the head end, midpoint, and service functions. Next, please. So still, we have some questions, and we already discussed with Art and the SEC area people. And here, we would like to discuss here. And one is about security issues, which has always been challenged to APN. And so what are the security issues when the APN attribute is used within the limited domain? So whether there are still some security issues, if there are, how we can mitigate them. And then it's about privacy, another question which are always being challenged. So we got some suggestions from the some draft published in the Intel area. And we could mitigate this issue by grouping the user's applications, that is using user group applications group. Actually, it has been there, and we just, we wasn't explicitly indicate. And so it's generalized. This attribute, APN attribute, is generalized. And also we can use an opaque value, and it's just a bit string. The network doesn't need to know who you are and what you are doing and what application is sending traffic. It's not helpful. It's not helpful, or it's not useful for the network to do the performance, to do the policy enforcement. So, and we should focus on describing the classes of policy to be applied to the traffic. So I will pause here, and so we can start discussions. Thank you.
Yes, go ahead, Linda.
Hey, Suping, it's a very good presentation with many of the questions I had before. So I just want to add one more comment to the MEF SD1 project. In there, there's a section on the application segmentation, application-based segmentation. They have a use case of like retail payment system. Like that payment system can only be mapped into certain topology, virtual topology, versus other application can be mapped to other topologies. I think that would be very useful to use APN concept.
Okay, good. So if you like, you could post this information in the APN mailing list. And
okay.
Yeah, thank you.
Hi, Shipping. Excellent presentation. Thank you so much for clearly explaining a lot of things. Actually, we've been looking into it. So the first thing I liked is, can you hear me okay?
Yeah, I can hear you. Okay.
Okay, so the first thing is you clearly separated. It's not from end host. It's not from application. So that's very clear, and that's a good progress actually. So it's from the edge devices, right? So that's that's the scope. So my question is,
Yes.
so this is my understanding as far as I see, this is for any data plane, right? It's not for IPv6 only, which could have been done with GSRv6 or SRv6 extension header, isn't it? Or
Yes.
is it only for IPv6? It's for any data plane.
Yeah. Yes. For any, it's decoupled.
Okay. Okay. Okay, so the other comment is you talked about the QoE issues in one of the slides use cases. So the two use cases, obviously, the whole multiple working groups have been discussing is slicing for sure. That's one of the holy grails. Like, you want to provide some determinism and kind of some SLAs into the a single domain network, and also on the specifically for 5G in the single domain, and also on the once it reaches the core, you need to have the service chaining requirements. So, are you targeting these specifically, or you're not touching the slicing topic, but in general, overarching QoE issues you are talking?
Actually, we don't. We are not. It's a general solution or mechanisms, and network slicing could be integrated with APN and using the APN attribute. So the mission critical traffic could be steered into the dedicated network slice. That could be one of the use cases of APN. And then for the SFC, I mentioned what benefits APN could achieve.
Okay. And the last question is, if it were to be done in IPv6, is it SRv6 or the new hop-by-hop extension header?
You mean SRv6 and?
If the APN, the extension header has to be done in with IPv6 data plane, so you said that it is generic, it's applied to any data plane, but if it were to be done in IPv6, I saw the GSRv6 hackathon. So the idea is with SRv6, or you guys are thinking of proposing a new extension header like hop by hop?
Okay, I see. So the APN, if the data plane is IPv6, and we could use the hop by hop options header, destination options header, and SRH. Within SRH, we could use the arguments of each state, and also the SRHTRV, and those places could be used to encapsulate this information. And it doesn't have to be related with the new hop-by-hop options header. This is what you mentioned, right? So no, yeah. It's that was not related with the work here.
Okay. Okay. Thanks. Actually, it's very clear now. Good presentation. Thank you.
Thank you. And maybe just one more clarification. So the work we are doing on the hop by hop, mainly the purpose of us is we want to make the hop by hop really usable for the operators for the network, because it really carries a lot of very key features and new services. And as we can see, so that is our main purpose. And after the presentation in the V6 Ops, we can see it has been agreed by the community and chairs. So it's like the problem statement has been agreed upon. So thank you.
Okay,
Just one more.
Basically the idea is you're coming up with some structure which transcends the extension header type, basically, right? That's what it's come down to, right? So not only the extension header type, but also the data planes. Okay.
Yeah. Thank you.
Okay, thank you.
Go ahead, Xinbin.
Yeah. Okay. Hello. This is
Oh, sorry. I muted. Sorry. I just to
Okay.
introduce
Yeah,
my.
Okay. Thanks. So for the last minute or so, there was no audio. So.
Okay. Yeah.
Start,
Okay. Thanks.
Start over at that
Chris.
point, I think.
Okay.
Okay. Thank you.
Yeah, I just the brief the introduction about my this is the presentation in today's the security session regarding this the they are thinking on the security and the privacy issue. I mean so that's the in general I think the people in the security area and the APP area not understand the user cases that always used in the routing area. The first one they talk about if this is the packet from this the mobile phone to the transport network. So how to derive this the APP group or the user group information at the network edge. So that is a answer that is this is the simple way we can according to the 5 tubes to map to an application group and the user group information. So that is can be used along with the network path. The second one, they don't understand why this packet 5 tube information can be directly used. So I told them that in the transport network, in the wireless transport network, so this original this the IP packet will be tunneled with the GTP tunnel and go on to with this SRv6 tunnel and the MPLS tunnel. Yeah, so that's the 5 tube information of the original packet cannot be got in the transport network, or is very hard to be got in the transport network. So the last question, so the question is that why not directly copy the original the 5 tube information from this the original packet to the tunnel encapsulation? So I think that this is the question that we know that use the 5 tube information, so they can call this the performance for call the forwarding performance issue. And also that's the because you know that's the match this the 5 tube need the complex the complex the forwarding algorithm. So that's the entry of this the scalability is also we will encounter the scalability issue. So that means that we cannot achieve the many entries for this the steering traffic or some this the other security process based on this the application group or the user group. So that's the additional information. So according to this introduction, so we can say that some of this scenario is easy to be understand in the routing area, but this is hard to be understand in the application area and the security area, because they always assume that the packet traverse the internet. So that's is my introduction. So I think that's okay, because this the introduction will be helpful to the cross area discussion and understanding each other. Okay, that's all. Okay.
Yeah, so I guess Kausik, if you have a question, and is it a question for Shuping? It would be good if Shuping could unmute again, I think. Okay, good. So go ahead, Kausik. You need to unmute yourself. So I'm seeing Kausik in the queue, however, I guess Kausik says he is having trouble unmuting. Okay, well, we have Okay. You want to type your question?
I think type it, we'll read it loud.
Yeah.
So shall I continue? Because I still have a few slides left over.
Okay, so why don't you continue, and then we'll pick up Kausik. Kausik is typing a question. Well, actually, so he's finished typing the question. So he says, I'm wondering how APN header would be integrated with MPLS or IPv4 data plane.
That is related with the solution, and we can do it, I mean, later. That is solution related. So we can investigate all together later.
Okay, but that's sort of within scope, I guess. That's a possibility. You're not excluding that possibility, I guess. Yeah.
Yeah. Chris, I can add some of the point.
Cannot hear you.
Oh, okay. Feel free to answer that a bit.
Okay.
Robin?
I wanted to add the point is that for the MPLS domain, because we have this extension header, maybe we can use some of the in fact this, I think this is a good question, and also you know that on the Friday there's also the meeting to discuss the MPLS encapsulation. I think this is also related with that one. And now I think that is possible you can use some of the special purpose label to indicate some of the extension information below the MPLS label stack, so that we can achieve the application information from the extension header that's below the label stack. That's a possible way. Yeah.
Okay. Thanks. So at this point, Shupeng, why don't you go ahead and finish your slides, because we're down to about 8 minutes left in this session.
Yes, so it will be very quickly. Next, only 3 slides, just to give people information. Thank you. So here I presented this before, and in the side meeting, and probably also in the RTGWG. And our plan is to have a working group, and but before that we will have an interim meeting, and hopefully above in the next IETF. And here are all the possible work items we could have. And next, please. And very quickly about APN activities, and we have 2 set meetings and a few hackathons, and I have listed all the link, so you can go into there to find more details and demos in Infocom. And we have the APN mailing list thanks to the AD, and that really triggered the discussions, and we have a lot of valuable discussions there. And so that's next. Yeah, so those are some references, so you could find the information about APN. Thank you. That's all.
Okay, thanks a lot. Let me just ask if there are any other questions for Shupeng before she drops off.
I don't see anyone in the queue.
Okay, well, I think that's everything on the agenda for this session. We have another session on Friday, so we hope to see you there.
Okay, thank you.
Okay,
Thanks, everyone.
Thanks a lot.
See you tomorrow.
Okay, bye-bye.
Bye.
Bye.
Bye.